Aerospace engineering is the primary field of engineering concerned with the development of aircraft and spacecraft. It has two major and overlapping branches: aeronautical engineering and astronautical engineering. Avionics engineering is similar but deals with the electronic side of aerospace engineering. Aeronautical engineering was the original term for the field. As flight technology advanced to include vehicles operating in outer space, the broader term aerospace engineering has come into use. Aerospace engineering, particularly the aeronautic branch, is often colloquially referred to as rocket science. Flight vehicles are subjected to demanding conditions such as those caused by changes in atmospheric pressure and temperature, with structural loads applied upon vehicle components. Consequently, they are usually the products of various technological and engineering disciplines, including aerodynamics, propulsion, avionics, material science, structural analysis, and manufacturing. The interaction between these technologies is known as aerospace engineering. Because of the complexities and number of disciplines involved, aerospace engineering is carried out by teams of engineers, each having their own specialized area of expertise. The origin of aerospace engineering can be traced back to the aviation pioneers around the late 19th to early 20th centuries, although the work of Sir George Cayley dates from the last decade of the 18th to mid-19th century, one of the most important people in the history of aeronautics, and a pioneer in aeronautical engineering. Cayley is credited as the first person to separate the forces of lift and drag, which affect any atmospheric flight vehicle. Over the years, this industry has seen a significant amount of enhancement at a global stage. On the contrary, there are some countries like Nepal, which seems to be left behind in this sector. There are only a handful of professional aeronautical engineers in a country where aerospace engineering is aircraft maintenance. Today, we have one of those rare gems that fall under the category of working aerospace engineering professional. He is Pratik Shrestha. He achieved PhD with a research background in SHM, structural health monitoring, and NDT, also known as non-destructive testing. That includes image processing, data fusion, machine learning for anomaly detection. Currently working as a development engineer in Fortin First, he has also worked as a researcher in Technobis, postdoctoral researcher in TU Delft that included machine learning algorithm development using MATLAB. In KAIST, he was a graduate research assistant in Smart Structures and Composites Lab and Intelligent Systems and Vibrant Control Lab. And he has also done an internship in Nepal Airlines Corporation. Only a few people from Nepal have gone on to have such a decorated career in this field. So, without further ado, let's go and meet him.
Yeah, like okay, so we have now like very accomplished aeronautical aerospace engineer with me. His name is like Pratik Shrestha. So how did it all start? You know, you taking the decision to become an aeronautical or aerospace engineer. You know, because it's not so common in Nepal and it's very risky. Yeah, I also have like after completing.
Actually, yeah, I mean, it's not really a common topic back in those days, but the credit really goes to my one of my uncle who was an inspiration to me. So I was just about 12 years of 12 to 13 years of age, and I was thinking of what to do in the future, what to become, as everybody goes to the same stage. And then one of my interests really was aircraft, and I think everybody is quite interested in looking at aircraft, and it amazes everybody like how the aircraft flies. So I was one of them, and at the time I did not know about what the field aeronautical engineering, but then there was an uncle, a common friend of one of my father, who was already an inspiration. He introduced me to another student who was pursuing to become an aeronautical engineer, and therefore that inspired me to brought me to this field, and then I pursued this engineering sector. So it has been a long journey.
Yeah.
That was back in 2004 or 5 when I decided to become an aeronautical engineer, and then I joined the aeronautical engineering school in 2006 in Nanjing University of Aeronautics and Astronautics, which is in China. Yeah, and well, basically, along with me, several other groups, several other people from Nepal as well in my batch, and many of them are actually working in the aviation sector in Nepal, also in Buddha Air and many other field. Yeah.
Asis, I think Manandar is one of your.
Yeah, he's my batchmate.
Yeah,
Asis is my batchmate.
Yeah,
we are friends. Asis, Kushal, maybe you know all of them. They're also in Buddha.
Yeah. So, like, what were the career opportunities like then when you were, just starting to study, and after, like, you have finished, right? So, what was your thought process after that? Because aeronautic is like really vast. Yeah, we don't know what to do after graduating, and we get baffled a lot. So
that's true.
Yeah, can you tell me how?
So I mean, and especially it's more challenging to us Nepalese because the aviation sector in Nepal is not that developed. So once we started this field, we don't know exactly what to do in Nepal. So that confuses everybody, and that was also pretty much the same for me. So, but after completing my degree, along with my friends, so when we were in Nepal, we contacted several aviation sector like Nepal Airlines and Buddha Airlines, and we got enrolled into this volunteering program to really get to see what's being done in Nepal. So in case of Nepal, that was the starting point. What we can really do is to get our hands on the aviation sector within the country. But that is it in Nepal, actually. What else can we do? But as I know now that some of the colleagues from my university back in from NUA, they did start a aeronautical engineering courses in Kathmandu University. So perhaps in the years to come, there will be a more vibrant industry in Nepal as well that can accommodate the aeronautical engineers who are graduating from outside. But then another aspect is for those who are not really into maintenance and these kind of things. The other option is to go into research. There are so many fields that what we can do in the aerospace industry, from propulsion to structures to you name it. So you already know that there really is a lot to do, and we can go into research sector, and that unfortunately takes us away from Nepal again. So to countries such as South Korea or China or USA or any other countries which has this more robust industry catering to aviation.
So, like, talking about research, what are the things like we have to do if you have to become an like if you become an independent researcher and write publish journals and project reports? So what are the steps?
Yeah, actually, in the beginning, it's quite challenging. Especially most of the studies in bachelor's, they don't really teach you how to write papers and this kind of stuff. But that was in the past. Nowadays, even in bachelor's, they already have started this process where they really focus on actually getting a paper out from their final thesis. But my own experience was that I had no idea how to write a paper or what to do. And so this is a process that I learned during my master's degree. And one important thing is really that the first part of the technical part, we can do that. We use software, so we do some sort of simulations, we get the result. But then how do we get a paper out of it? And that is really, there's this course called scientific writing, which I really highly recommend. It really gives you an outline of how to prepare yourself for the scientific journey. And that can be the first start for anybody who wants to write a paper, to know how to write a paper, to get the outline of writing journal papers. And that's just one part of it. There's a whole, so that's one part of it. And then there's many other things that we also need to consider. For instance, there are so many different kinds of journals that you can publish in. And we also need to consider which journals that we want to publish in, and is it worth publishing in a journal that we have selected. So these are all the things that we really need to consider. It's not just enough that we have we have content and we want to publish it. That's not enough. We also need to decide on which journal that we should is suitable for that, and is it suitable enough to publish such kind of your material on that journal or not. And that comes with experience, actually. But then the first step is really to start.
So, like when I was in college, right? So I had like a project report, but the topics were already sent from, you know, the other from
Yeah.
professors. If you have to look
Okay.
for genres, topics for ourselves,
Yeah.
so where to start? Because I've been asking like, and they said there are like little topics they can or something like that. Are there like
So you're talking about publishing. You're talking about publishing, or you're talking about doing research?
the research also, like we have to write some topics that are really needed, right? We should not
Yes.
be
Something
writing
new, something novel. Novel.
yeah
Yeah.
something new about that. So would we get that on the sites of the professional the authority websites?
So actually, the first the step really is to write a paper. First step is the literature survey. So during the literature survey, you have to identify what is lacking, what has already been done, and what is lacking in the industry. And once you identify the missing links, then you begin your research process. You do your experiment, you do your simulation, you do your models, you get results. And once you have some findings, then you identify, is it new or not? You compare it with your literature. And then based on that, you can prepare your manuscript and see, and you can match your manuscript to the journal that entails all those different topics. That's really the whole process. And in order to do the literature survey, there are a lot of journal papers that you can have access to. But unfortunately, most of them are behind the paywall. So you need to pay to get access to many of the literature. However, there are a lot of also open sources documents which you can use. And then the other option is really this website called ResearchGate. So basically, this is a platform where researchers can communicate with other researchers. They can upload their papers, and if they have not uploaded the papers, you can also contact the researcher directly and then ask them if they can provide you with their paper. And so that's one way of accessing journals that you might not have access to easily. So I recommend joining ResearchGate if you are not already there.
So like after after we select our topic, should we submit like uh, inform it to the governing body, or should we start our process? Because
So, so depending on it depends on the journal type. Some journals specify how to write in a particular format, but then some journals they tell you to you can write in a freestyle, and then they will do the copy editing later on. So before you submit a paper, what you really have to do is you have to go through the journals and then see what their regulations are. So it differs from journal to journal actually. Yeah.
so coming back to like aeronautics, what do you think is the future for aeronautics? Like the like, do you think we will have some personalized vehicle like for the urban for like everyone will have a flying car or something hoverboard? Do you think
Yeah,
it's coming is soon?
that I think
I
that
think this
is
will be
like
like
really.
really cool if
Yeah, I do see that happening actually. I do see that happening. In fact, you might have already seen this hovercrafts, which you can basically it's kind of a drone where
hoverboards.
you can stand on and then you can control it. Hoverboards, yeah, but with the quadrocopters with the four those rotor blades. So that's already out. So it's just a matter of time when it will be out for public access. Maybe not for everybody, but maybe in a kind of in an enclosed space where you can try it out. But maybe in the future, you never know. These kind of things can go mainstream. It is possible. We are already in that direction actually, and uh, so there's a lot to come in the aerospace industry. A lot of things will change, I think. And one big change might be that I think conventionally we are used to flying in a kind of a cylindrical body with two wings. So maybe in the future that conventional design might change. If you look at when I was doing my postdoc here at TU Delft, in this university, they are looking at designing a V-shaped aircraft. So basically, it's a flying wing concept. There is no separate wing and separate fuselage, but just a single wing which is flying. And the other changes is in the direction of uh, the environment is having aircraft is a big polluter. So I think a lot of changes will take place to make this kind of aircraft to become more environment friendly. Maybe I expect we will be having this kind of hydrogen powered aircrafts, and also maybe a solar powered aircraft as well. So there's a lot of research going on in all these different fields, and yeah, and also I think the as you mentioned, more personalized vehicles might be also on the horizon. Uh, a kind of a drone, so a person driving a drone.
Without like if that would be very cool. If they could fly without license, they don't need any license, and
Well, I
everyone
don't think
has
that definitely
like everyone.
I mean, the whole aviation industry is highly regulated, and definitely
Yeah.
when they personalized flying devices, that they will also be highly regulated. Therefore, it will not be just a matter of license. There will be, I think, a lot of paperwork behind. It will not be like just getting a driver license. It will be probably more than that. Maintenance of the aircraft, maintenance of the drone and things like that. So yeah, that's an interesting feature that we can look forward to. It might even happen in our own time, in our own lifetime, within our lifetime.
So, like, what do you think is really stopping them from happening? Like I think the technology side is almost done. I think the regulations and everything. I think those are the things that are stopping because, first of all, it may be if you have like personalized device, it may be like very noisy, right? So it may be like and security may be another reason for it
I think
to
both
not happen
actually.
right. Yeah.
In terms of technology, I think maybe we are not there yet. Definitely, we have a lot to do. A lot of research has to be done to ensure that these devices can be available for public use. And then the regulation side, I think that's also very important, because we don't want anybody just flying out with this kind of personalized vehicles. So the regulations are there to protect you and the people around that particular vehicle. So I don't see the regulations becoming any easier than it is already. Than it is. I think it will be more stricter, and that yeah, that's how. But in terms of technology, there's a lot to be done. I think we can. There's already a lot of research going on in terms of developing new materials. For instance, my own work is investigating the structure health monitoring applications for the composite structures. And I'm not sure if you are aware where the composite structure is, but it's like a kind of a mix. It's a reinforced plastic, which is lighter than metal, but at the same time, it's very strong. So these kind of composites are also used.
Strength to
Like
weight ratio is much more with
yes, exactly. And you might have heard of the carbon fiber reinforced plastics, and there's also the glass fiber reinforced plastic. They are being used more and more these days in the aircraft's components. And the new Boeing that we have now, and the new Airbuses, over 50% of their the parts are made using composite. And the goal, I think, really is to have the entire aircraft to be made using composite and not just metals. And for that, a lot of research had to be done, because one main obstacle is that these new materials, we don't know how they behave. They have different behavior compared to the metals. And therefore, with these changes, it brings about challenges in terms of certification. And so a lot of research has to be done so that we can ensure that these materials are safe enough and can be certified by regulatory bodies such as FAA and the kind of stuff. Yeah. And my own work actually is a bit. I'm more on the research side actually. I'm working on the structure health monitoring, as I mentioned, and so the concept is also quite interesting in that. I'm not sure if you know about what SHM is, but basically the idea is mimicking the human body. So we have our body. We have in our body we have this nerve cells, and we have the sensing parts, and it's constantly communicating with the outside world. We know what's going on around us, and we can feel the temperature dropping, or things like that. We can feel the pressure through our skin. So we want to have the same kind of concept in our aircraft. We want the aircraft to be smart. So we want to know whether we want to know how much load is the aircraft experiencing in real time. We want to know if any kind of load had a severe impact on the aircraft. We want to know if there is a damage that was not detected, or during its operation. We want to know if there was some kind of damage that occurred, and we want to do that in real time. And conventionally, what is done is in a maintenance-based approach, what was being done is they look at like a periodic maintenance. So basically, with the air, probably what you do is every 6 months or every 3 months, there's a certain maintenance that you have to do.
Yeah,
exactly right. So, but then maybe it's not necessary, but still you have to do it, because in the guideline, in the regulatory board, it says after 3 months or after 6 months, you have to change this part. You have to change that part. But and if you don't have to, and if there's nothing wrong with that part, and if you still have to change that part, that means the company is losing money, right? So we want to change that concept. We want to have a kind of move away from this approach of doing this periodic maintenance to just in time. It's called just in time maintenance. So basically, only do maintenance when it's required. And for that, we are looking into embedding sensors in the composite in the aircraft structure to be able to see if there's a need for maintenance or not. And yeah. So there's a lot of work, a lot of research is going on. And yeah, if you have any question,
that's very cool.
yeah. And it's
So
really interesting actually.
like,
I can
because
tell a bit more about my work.
yeah, sure, sure.
And the structural health monitoring can be done using many different kinds of sensors. There are different kinds of sensors that can be used, such as piezoelectric sensors, which are in short is called PZT sensors. I'm not sure if you know about it.
But like structures that expand, I think,
Yeah.
yeah, that one,
So
yeah.
if you feed electricity to it, then it will expand and contract depending on the positive or negative charge. And if and vice versa. So if you apply pressure, then there's the electric current that is generated. So this sensor can be used for SHM, and there's another kind of sensor called fiber optic sensors. And basically, these are like so the general fiber optic cables that are used in for connecting us to the internet. The same fiber can also be used as a sensor by when there's some sort of grating in there in the sensor, and they can be used for sensing temperature and strain. And that is what I'm using. So basically, the idea is to embed this kind of fiber optics, which are very, very small. It can be as small as 100 micrometers, or even less, about 80 micrometers as well. So it's very small. And the main advantage is that you can embed it, basically embed it in the structure, and that allows you to monitor the inside, to perform in situ monitoring of the structure. So that's what I'm actually working on.
All the best for that.
Yeah.
And so it's really cool. That would be like, so like when you develop all these things, do you keep in mind about the maintenance procedures as well? Because you have to make it easy for the guys who do maintenance also, right?
Yes.
Or
Well, at the moment, the work that I do actually is still in the research. So it's still in low tier level research level. So basically, the TRL level stems from 1 to 9. And what I'm doing is somewhere in between TRL 4 to 5, in which it's still in a research phase. So probably when the TRL level increases, it goes to 7 or 8 or 9, then all these factors have to also be considered. Definitely, one challenge is the maintenance aspect. How can we incorporate these kind of sensors so that they can be easily be maintained or changed in the aircraft? So that is also a challenge that needs to be solved.
so like you told about the alternate fuels, aircrafts using alternate source of fuel like the hybrid hydrogen plane and the
Yeah.
solar power plane. So what about electrically planes that run on electric power, solely on
Yeah.
electric power?
So like a solar powered aircrafts. Yeah, and that can it all depends. That is possible. That is possible. But perhaps it might maybe for a small aircraft that is already the case. That is already possible. But for larger aircrafts, I think that is quite a challenge. They require a lot of. For instance, if you want to fly a commercial aircraft like Airbus 380, then probably a hydrogen powered vehicle is what we are looking into. It's cleaner and it's challenging and interesting at the same time.
So like coming back to like the student's perspective, right? What are the softwares that we really need to learn if we like are to get into the aerospace industry? CATIA 5 is one, ANSYS is one. I've learned like SolidWorks. CATIA 5 I've not learned. So what are the softwares that you recommend to learn?
It really depends on the field that what you're working on. For instance, for the structural engineers, I think CATIA and ANSYS and even Abacus, they are quite good. For composite The Abacus is quite good. And then for people who are more interested in aerodynamics, there are really different kinds of software that can be used. For instance, Fluent and Gambit and Fluent, and also there's this hypermesh based programs, as well as and there's like it really depends on what field you are in. But I think the basic thing that everybody has to learn is you already mentioned it: CATIA, SolidWorks, and all these softwares I think are necessary.
So like, do we really like need to be really good at it, or is it good if you do it, like on a functional level if you learn it?
So when you are in a bachelor level, I think functional level is enough. But when you're doing your masters, and you need to really as you progress with your work, you need to become more knowledgeable. You need to go more in depth. So it depends on your level as well. For people who are doing masters and PhD, then they really need to know the software in details. And then once you go into the industry, so basically the industry may have their own standard, may have their own software that they're using. So it's not one solution fits all. It's tailored. It needs to be tailored.
You have to look at where we are and what we are going to do, and then work and
for a student, I think for people like for bachelor students, I think it's good that they know they are like they use all of these softwares. They know how they work and know the basics. I think that's enough. But for master student, because they are working on more specific topic, then they will have to become an expert in the software that they're working on.
So, like one more question is that do we really need to be a good component in Excel as well, the data, keeping data and everything?
Yeah. So now I think. Well, do we need to? The question is, do we need to? Why not? The answer can always be why not. It's always good to know. But then there are also different other kinds of software that can be also used for the same work. So the answer is always why not. You can always learn. You can always be good at whatever you want to do. And and if your question is more about data analysis, then I think data analysis is quite a emerging field, not just in virtually every field, and also in aerospace industry. And the buzzword I think we missed earlier is the artificial intelligence. So one of the future for aviation is also the AI-driven aviation industry. So in the future, you'll be having these aircrafts that are powered by AI, which is independently flying the aircrafts without any external inputs. So I think that will happen. And for that, the main component is data analysis.
So like you mentioned AI, I was having a question about AI as well, with like proving AI enhancement in AI technology every day. So I think like most jobs will be like lost due to it. So what do you want?
I think certainly a lot of jobs, the AI or this automated automation will certainly will definitely take a lot of jobs. But I think at the same time, it will bring about a lot of other opportunities as well. So it's not necessary that all jobs will be lost. Certainly, jobs like pilot job might be gone in another 50 years because there are already like automated cars coming out, and they can also do the same for the plane as well. And but then at the same time, I think other industry might open up for us to explore. So certainly, I think a lot of jobs will disappear in the future. And it can be sooner than later.
The main question is like how can you prepare for it, or we should just be open to like whatever comes out, whatever openings that we see at that time, we should be
Yeah. Actually, this
going
question is
accordingly.
this
Okay.
question is very this question is this is really a question for us, for our generation, because we need to think about this. And one way to prepare for it is to also be aware of how this machine learning based algorithm works, and get yourself acquainted with it. Learn yourself how to develop program to develop machine learning algorithms. And machine learning can be for basically any kind of application, even for software analysis. I'm sorry, the structural analysis. You can develop your algorithms using the AI techniques. So this is something that I think we all should look into, and we all should develop our skill into, to prepare for the future.
Yeah.
Yeah.
So like coming back, for an aeronautical graduate, how feasible it is to make a like establish a startup, and like for example a drone company, or maybe a
Yeah.
parts manufacturing company. So how feasible is it?
So it really depends. So this question is not a straightforward question. It depends on which country you are in. So it depends on it's dependent on the policy of the country, as well as the resources that you have around you for that. For instance, in Nepal, I think to make a drone, I think also depends on what is your target market. Is your market like like for either like a toy, or is your market for like a more commercial application in the agriculture industry, or in in an industrial scale, or is your target also the defense? So there's this whole range of it's a big market that we do need to consider. And first, I think if we are interested in making this kind of startup, we have to invest time in developing policies that allows us to enter into this kind of startups. In the Western country, it's quite making a startup is relatively very straightforward. It's very the process is not that complicated. If you have an idea, then there is opening up a startup not that difficult. But in a country like Nepal, I think I'm not sure. I think the policy that needs to be looked on. Yeah, because in a Western country, they really want everybody to, they really want people to go for the startup. If you have some idea, then go for it. That's the concept, and they actually give you the space for it. They give you, and if your idea is good enough, they even give you funding for it. So yeah, I think that's something like that has to also be done in Nepal, and I think there's already being done. That's already being tried on. As one of my colleagues, I think he's trying to work on it to have this kind of a startup ecosystem in Nepal, and startup can be for anything, and particularly for us, we can think about this kind of things like making a drone, or and why this drone? We can even make a startup for like a small aircraft. We can dream big.
Yes, yeah. For what for like parts manufacturing, like the small things like made for composites, like the louvers, air outlets, and something like.
Yeah, and so yeah, I mean, so it's one thing about one thing is this, as you mentioned, the startup for component level manufacturing, but you also have to consider the market around it, the market there or not. And so basically the whole ecosystem has to come up together. So if you just want to make one product component, that's not enough. The whole ecosystem has to be there. So there needs to be this kind of a society that really encourages everybody to work together separately, but at the same time for a common goal. So that needs to happen in Nepal as well. Something that we should do.
Yeah, and what about in the West, like in the inner side?
Well, in the Western society, the thing is, they have already done a lot of work, so they already have a lot of support system. So, for instance, if a new startup wants to come up and do something, they want to develop some particular component, then there's already a market that can absorb that component because they might be needing that. So the market is there, market is existing. So it's relatively the process is, I think, relatively it's different, definitely very difficult, but at the same time, it's a bit relatively smoother because the ecosystem exists in there, in this kind of Europe or in America. But in other countries, we need to think more in detail. We need to think more details about what has to be done.
This is a bit like skeptical question, right? Because some of friends, two or three of my friends, did suicide because they had low grades and they did not, have like jobs for like quite some time.
Mhm.
And if what are the ways for an aeronautical students, if they have low grades and they want to work in this field? So is there any way, or should they change their field? Or because two, three
Mm.
of my friends in India, they committed suicide. So
Okay.
whether I should asking this to you or not.
No, I mean that's actually that is indeed also one part of the reality that happens, and I think that's not just in aeronautical. I think that's in like basically every field. I mean, when people fail and when they don't meet when people don't meet the expectation, the last resort they think is probably to give up. So what they can really do is, I mean, just to keep up, I mean, not to give up hope. There's always, I mean, if something does not work out, there's always something else. I mean, we don't have to really, we don't really need to stick ourselves to one thing. I mean, it's a matter of exploring other things as well. And if you are really
Because I
and if
think
you
they
really
can get
are,
other trades in the aviation field if they don't work in the aeronautical, then they can get license and everything.
I mean, yeah, I
They still
mean, if that's not possible, if they had not succeeded in doing that, then suicide is not the last option. I mean, they can do other things. They can still be within their aeronautical field, but do some other things. Maybe like go into manufacturing of components, like you mentioned. Explore this kind of things, or maybe like you mentioned making drones. So drones is really a big market in every country nowadays. Everything is being done using drone. Last time I saw, even the police in the US are using drones to, catch thieves. I'm not sure if you have seen that video, but so basically, it's in the US. What they did was, in the past, the police would knock down their door and then go inside and say, "Okay, police, get out." But now what they've done is they use a drone to smash the door and then go inside, and then just point a laser at the criminals and then catch the thief. So basically, the drones are being used everywhere. So that's something that can also be more business rated, some more kind of a business development case that can be looked on. Not necessarily working directly in the aviation industry, but this periphery of this aviation industry can be worked on. So yeah, the outlook does not necessarily have to be so gloomy. I mean, if one thing does not work for you, there's like thousands of other things that you can do.
yeah. So according to you, right, what are the skills that an aeronautical engineer must have? The mindset and the skill.
I think determination, hard work. I think they are the crucial things. And of course, you need to keep up with the current trends. There's a lot of changes going on, and if you want to work in the maintenance side, that's a different story. But if you want to work in more research side, then you have to prepare yourself accordingly. You need to do more research in terms of what field exactly do you want to go into, or which university that might suit you, which country will suit you, and these kind of things. So all these things need to be looked on.
So, like one last question for you. What do you think about the current? I actually have two questions. What do you think about the current education system of the aeronautical or the aerospace engineering? And if do you think that there should be any amendments to it?
Well, I think at least in my case, I think it's the same in all the universities. They have like the first year is the basic. They go through all the basic stuff. The second year they go into more details, and the third and fourth year is the more specifically related to the aeronautical related subjects. So I think to me, I think that it works, but nowadays it might be already actually not. It's already the change is already happening. Especially here in TU Delft, where I did my postdoc. Even the bachelor student, they really work in a group. They are really taught to work in a group, and they are really taught to come up with something, to really challenge themselves to solve real life problems. And I think this is something that can be incorporated already in the other universities if that's not already happening. So basically the courses does not really necessarily have to be only you read a book and you give the exam and you pass the test, but really about at the end when you come out of your education, you don't really work by yourself. You always work in a team with several people. So maybe one is maybe a structural engineer, one is maybe aerodynamicist. So yeah. So I think a similar thing can be done, and a similar thing can be mimicked in university scale. So basically, one team can have there can be like a structural engineer, aerodynamicist, and maybe like a propulsion expert within a team who are working in a project. These kind of things can already be done, and I think this is quite a practical thing that needs to be incorporated. Not just in aeronautical engineering, but also in other fields. So a more practical approach to education, not just reading and passing the exams. And also in the past, my own case was that we would have like a thesis at the end of the year. Like in the fourth year, we had to work on a thesis, but that was still like it's a one-man job where you work on your own project. But I think that is in today's world, we need to change that. I think it has to be like a work of a whole team working on one big project, but everybody on their own component. But the goal is like one goal, maybe to make an aircraft, or to develop something new material, or develop new technology. So that can be done.
So like this one's a pretty final question. What do you think about the aerospace industry post this whole pandemic? Because maybe the demand manufacturing planes may be like less. Aviation is almost it has hit the aviation industry. But what do you think about the aerospace industry?
Yeah, I think the aerospace industry has been hit hardly by COVID, and that is we can already see that in Nepal as well. Like I think majority of the aircrafts flights are cancelled, or even the ones that are flying with very low number of passengers, and that has had a big consequence because the airlines which had planned to buy like several hundred aircrafts have decided not to go ahead with their orders, and therefore the companies have had to cancel, close down certain factories, or let go of their the workers. So it has had a ripple effect, and quite a really difficult time for the aviation industry. But then I think we should be optimistic, and I think the aviation industry will somehow evolve and figure out how to work around even in this kind of difficult situation, and it will eventually come back to how it was. Maybe not exactly the way it was in the past, but in a modified form, it should get back to its feet. Not immediately, but maybe it might take several years, 2 to 5 years, or even more, to come to like 2019 level, scenario. So yeah, we should remain optimistic. Difficult times ahead, but we should not give up hope.
Okay, so thank you very much. That this was it for for today. It was really nice talking to you, to such a accomplished and a knowledgeable person like you. Yeah, as I said before, I was very nervous to talk to you before.
No, it was very nice talking to you as well, Satyam. Really good to talk with the budding enthusiast, and you're yourself an aeronautic engineer. So I think you're already involved quite, in the day-to-day activities, and definitely I hope what I have said today will be helpful to you and maybe anybody who listens to this topic through this podcast.
Thank you very much. Thank you very much.
Thank you too.